lesson is on the chain rule, but before we get to that, I'm going to review rational exponents to make sure we have that squared away. So this is a nth root of x to the m, and you can't take the derivative of a radical. You have to rewrite it, as you know, using rational exponents. So to rewrite a radical using rational exponents, you take the number that's the exponent that is with the number in the radical, and it goes in the numerator, and the number that's the index, which is in this little v, goes in the denominator. Now we know that, but I've over the years seen a lot of mistakes. So like if you had this, that's the square root of 3, there's an understood exponent of 1, 3 to the 1, and there's an understood index of 2. So this would be 3 to the 1/2 because the exponent was 1 and the index was 2. Okay, but if you had like the cube root of x squared, the exponent isn't 1 anymore, the exponent is 2 and the index is 3. So this would be x to the 2/3. Now I have some people that do it this way and it gets them into trouble. For some reason they memorize that there's a 1 there and they do this and they say that this is x squared to the 1/3, and that just makes things super complicated. So don't do that. There's already an exponent. You don't need to add an understood 1. You've got the exponent 2. So I'm hoping that that doesn't happen anymore. Alright, so let's keep going. So if we had the fourth root of 6x plus 1, alright, so the first time here we have two expressions under the radical, so you would have to put parentheses around that and think of the exponent, understood exponent 1. So that would be parentheses 6x plus 1 to the 1/4. Okay, but if you had the cube root of 2x minus 5 to the second power, again, you would not need to add an exponent. There's already an exponent there, so don't make it harder than it is. That's 2x minus 5 to the 2/3. Okay, so those are just a couple of quick review expressions of radical and rational exponents. Okay, so here is the chain rule. So you're going to need to use the chain rule when you have more than one term added or subtracted to a power. That's when you're going to need a chain rule. But before we get there, we have to see that what I'm starting with is an example with a square root. And as I said, you can't take the derivative of a square root. So the first thing you have to do before you can differentiate y is you have to rewrite it, which that's right here. So rewrite, that's y equals 3x cubed plus 2. There's an understood exponent of 1 outside that. You wouldn't use that 3. You can't separate these. So that would be 3x cubed plus 2 to the 1/2 power. Okay, so you first have to rewrite. Then here's how you're going to differentiate. And we use the shortcut rule, and we use words to explain it. So what you're going to do is you're going to look at this, and the inside of this parentheses is 3x cubed plus 2. That's what we call the inside. And this whole thing, if you think of it as one thing, it's being raised to the 1/2 power. Okay, so the chain rule states that you're going to differentiate the bracket or the outside, leaving the inside of the function. And so what that's like is you want to leave the inside of the function alone. So think of this as y equals, instead of 3x cubed plus 2, as just one thing, like u to the 1/2. Okay, that would be the derivative of y would be 1/2 u, reduce that by 1 to the negative 1/2. So that's what we mean by take the derivative of the outside. That means basically pretend like that's just one thing. U to the 1/2 is 1/2 u to the negative 1/2. Okay, so what you're going to do, the first step, is to take the derivative of the outside, and that's what we mean. What we mean by that is you just pretend that that's just one thing. So that would be 1/2 times the one thing to the negative 1/2, leaving the inside inside alone. Don't do anything because it's just u. 1/2 that thing unchanged to the negative 1/2. That's part of the chain rule. The second part is you multiply by the derivative of the inside, which is 9x squared. So the chain rule is it's the derivative of the outside times the derivative of the inside. So it's not very written very well with a lot of symbols. It's a lot of words, and so you have to know what we mean by the derivative of the outside. So what we mean is you don't mess with this at first. You just pretend it's like u to the 1/2, 1/2 u to the negative 1/2, then times the derivative of the inside. Okay, so let's practice. So if we had this one, we have a binomial, 2 terms to the 5th power. So we don't want to multiply. This means 3x minus 4 times 3x minus 4 times 3x minus 4 times 3x minus 4 times 3x minus 4. You can't distribute the 5 in over addition or subtraction. So if you want to take this derivative, you're going to need to use the chain rule. When you have more than one term in here, you're going to need to use the chain rule. So the chain rule is the derivative of the outside. So you're just going to think of this as one thing to the 5th power. So the derivative of u to the 5th is 5u to the 4th. Okay, so look at this. The derivative of the outside, that would be pretending that that's just, you're not going to change that. This u to the 5th is 5 times this u to the 4th. So that's the derivative of the outside. And the chain rule is the derivative of the outside times the derivative of the inside. So the inside is 3x minus 4. That derivative is 3. And you can leave it unsimplified, or since this is pretty easy and multiplication is commutative, you can go ahead and multiply 5 times 3 and get 15. 3x minus 4 to the 4th. So that is the chain rule there. All right, let's keep going. All right, this time we have a number in the front, 4 times 5x squared minus 3 to the 7th power. So this is a chain rule because this parentheses where the 5x squared minus 3 is, you're just going to think of it as one thing. So I like for you guys to write it out with the u so your brain can learn to see this. So this 4 is okay, and then that parentheses is u, and then to the 7th power. So what's the derivative of 4u to the 7th power? Well, that's 4 times 7, that's 28, and then u to the 6th power. So we're going to take that derivative just like that, except this is u, so we're just not going to do anything to this parentheses. Whatever's in here doesn't change. You're just going to think of it as 4u to the 7th. So that would be 28u to the 6th. And don't change what's in here. That's when you're saying take the derivative of the outside. That's you don't change the inside, but that's just part of it. Then you take the derivative of the inside and multiply it. So derivative of the outside, we did that, times the derivative of the inside is 10x. And you can leave it just like that. You do not have to simplify. If you wanted to simplify, multiplication is commutative. You could simplify that to 280x. 5x squared minus 3 to the 6th power. All right, let's see another one. Okay, so example 4, we have a negative in the front, 5x over x plus 2 quantity squared. So first of all, that minus in the front is either going to belong to the numerator or the denominator, never going to belong to both. So this would be better if we just gave that to the numerator. All right, the second thing is, now you could use the quotient rule, but I want to teach you a new way. The chain rule can take care of this if we do a little rewriting and if we use negative exponents. So remember, a to the negative n is 1 over a to the n, but 1 over a to the negative n is a to the n. So a negative exponent just says flip me and make me positive. So a to the negative n over 1, that goes from the numerator to the denominator, but then the negative exponent changes. So 1 over a to the negative 1, that a to the negative n goes to the top as a to the positive n over 1. So I'm going to rewrite this using negative exponents. This isn't me taking a derivative, it's just me rewriting. So that would be 5x, instead of divided by x plus 2 squared, I'm going to move that x plus 2 squared to the top, so that would be x plus 2 to the negative 2. And now I don't have to use the quotient rule, I can use the product rule. Okay, so the product rule is the first times the derivative of the second plus the second times the derivative of the first. And even though we don't have parentheses, this x, this isn't a constant, this is it has a variable with it, so this x means that this is my first. So the derivative is the first, negative 5x, times the derivative of the second. Now the derivative of the second is x plus 2 to the negative 2, so you're going to need to use the chain rule right here. So what is the chain rule? The chain rule is the derivative of the outside times the derivative of the inside. So start by thinking that as one thing, u to the negative 2. U to the negative 2 is negative 2u to the negative 3. That's the derivative of the outside, times the derivative of the inside, which is just 1. Okay, back with the product rule, plus the second, which is x plus 2 to the negative 2, times the derivative of the first, which is negative 5. And you're done. That's it. You don't have to simplify. I don't want you to simplify. Okay. So next one, very same thing. Of course, you can pause me at any time, try it yourself. So this one, I don't want to use the quotient rule, I'd rather use the product rule, so I'm going to move that up. This is a rewrite. F of x equals 4x times 2x minus 6 to the negative 3. So the product rule needs to be used here. So that's first times the derivative of the second plus the second times the derivative of the first. So the derivative is the first, 4x, times the derivative of the second, and we're going to need to use the chain rule. So u to the negative 3 is negative 3 u to the negative 4. So this to the negative 3 is negative 3 times this to the negative 4. That's part of it. That's the derivative of the outside times the derivative of the inside, just the 2x minus 6, which is just 2. Okay, so where were we? First times the derivative of the second plus the second times the derivative of the first. Okay, now you don't have to rewrite, you could use the quotient rule. So if we use the quotient rule, that's bottom times the derivative of the top minus the top times the derivative of the bottom. So let's see what that's going to look like. So if I don't rewrite it and I just go with what I've got, that quotient there, and I don't turn it into a product, I've got a bottom and I have a top. So the derivative would be the bottom, 2x minus 6 to the third, times the derivative of the tops. The top's 4x, so that would be 4, minus the top, which is 4x, times the derivative of the bottom. So this time, when you get to the derivative of the bottom, you need chain rule. Okay, so the bottom is 2x minus 6 to the third power. So the chain rule is the derivative of the outside, u to the 3, so that would be 3u to the 2. So don't change the inside, times the derivative of the inside, which is 2. Okay, now where were we? We did the bottom times the derivative of the top minus the top. All of that is the derivative of the bottom. Okay, now we remember that we have to do all of that over the bottom, which is 2x minus 6 cubed squared. So the rule here for this exponent 3 and this exponent 2 is you can multiply together those. So you could leave it that way, but it's easier to type in if you just realize that that's 2x minus 6 to the 6th power. So you don't have to use negative exponents. I just prefer the product rule. You could have used the quotient rule, but you're going to have to use the chain rule at some point. Alright, here's a couple more to practice. You can pause the video and see how you do. Alright, so this one you don't have to rewrite, you're just ready to do the chain rule. So this would be like the derivative of the outside, so you just ignore what's in there. U to the 1/5 would be 1.5, this to the negative, subtract 1 and you get positive 0.5. So that's the derivative of the outside, positive 0.5. 1.5 times negative 3x plus 2 to the positive 0.5 times the derivative of the inside, which is a negative 3. Okay, if you were going to do number 7, 7 is 4f of x equals parentheses 2x squared plus x plus 1 to the negative 3. So the derivative would be the derivative of the outside, since there's more than one term in here. So u to the negative 3 is negative 3 u to the negative 4. And when I write down the inside, I'm not changing it. That's the derivative of the outside times the derivative of the inside, which would be 4x plus 1. So the chain rule is the derivative of the outside times the derivative of the inside. Okay, a couple more. So here you have f of x equals the square root of 3 plus 4x squared, and you can't take a derivative of a radical, so this one you're going to need to rewrite without taking the derivative, and that rewrite, remember, is what's under the radical is 3 plus 4x squared, so that has an understood exponent of 1 and an index of 2. So the derivative is the chain rule. So this is just one thing, u to the 1/2. So we're going to take that derivative. That would be 1/2 times u to the negative 1/2. So I'm writing this inside. I'm not changing it. That's the derivative of the outside times the derivative of the inside, which would be 8x. Okay, and then number 9, g of x equals parentheses 2x plus 4 over 3x minus 1, all of that to the third power. So you've got a lot of stuff going on in this parentheses. So anytime you have a lot of stuff going on in the parentheses, this time you have a quotient in the parentheses to the third power, that's chain rule. Okay, so the chain rule is the derivative of the outside. So this parentheses is making that 2x plus 4 over 3x minus 1 are one thing. So this, think of this as just u to the third. So that would be 3 times all of that to the 2. So I'm going to copy that down. So this kind of method helps me remember I should just be copying down the inside. I'm not, don't take the derivative of it. So this is the derivative of the outside, where we pretend that that's just one thing in there, times the derivative of the inside. Well, the inside is a quotient, so we need the quotient rule. So the quotient rule is bottom times the derivative of the top minus top times the derivative of the bottom over the bottom squared. Okay, so I'm going to use this bracket here, and so I can keep track of my numerator and denominator. And see, it's got a minus in the rule, so we're going to have to make sure we distribute. So that's why this bracket's very important. Okay, so here we go. Bottom, the bottom is 3x minus 1 times the derivative of the top. The derivative of 2x plus 4 is 2 minus the top, which is 2x plus 4, times the derivative of the bottom, which is 3, all over the bottom squared. 3x minus 1 is our bottom. We're going to square that. So we have the derivative of the outside, 3 the inside to the second power, times the derivative of the inside, which required the quotient rule. And you do not have to simplify. I don't want you to, really, because I can check it a lot easier, and so can you. You can check your work a lot easier. Alright, here's one pretty much the same, so you can try it. Actually, it's harder. So what this one is, it says g of z equals parentheses, and then you have 3z squared minus 9 divided by parentheses 2z plus 4 to the third power, all of that raised to the 5.2. So this is a chain rule within a chain rule, and a quotient rule on top of that. Okay, so there's no radical, so I'm just going to start. You might want to try it. So the first thing is this parentheses is what we need to deal with first. So this is u to the 5.2. So that's 5.2 times all of that to the 4.2. So I'm going to copy down all of that in the inside. 3z squared minus 9 over 2z plus 4 cubed, because I don't have to mess with the inside when I take the derivative of the outside. So the chain rule says it's the derivative of the outside times the derivative of the inside. Well, for you now it's time to look at the inside, and it's a quotient. So the quotient rule is bottom derivative of the top minus the top derivative of the bottom. So here we go. I'm going to use a bracket, so because I have a minus here. Oops, I'm sorry. Go back. Quotient rule is bottom derivative of the top minus top derivative of the bottom over the bottom squared. Almost forgot that. Okay, so because of this minus, though, I need this bracket here. Okay, so time to take the derivative of the inside using the quotient rule. So it's bottom, which would be 2z plus 4 quantity to the third power, times the derivative of the top, which is 3z squared minus 9, so that's 6z, minus the top, which is 3z squared minus 9, times the derivative of the bottom, which is a binomial to the third power. So there it is, the chain rule again. So the derivative of this bottom right here needs the chain rule, derivative of outside times derivative of inside. Okay, so we're going to think of this 2z plus 4 as u cubed. U cubed, that's 3u squared. Well, that inside, I don't change it, so that's 2z plus 4. That's just the derivative of the outside, though. And now we have to take the derivative of the inside, which is 2. Okay, so that's worth checking again. So we have bottom derivative of the top minus the top derivative of the bottom, which was chain rule, 3 times 2z plus 4 quantity squared derivative of the outside times the derivative of the inside. All of that over the bottom, 2z plus 4 to the third power squared, so that's to the 6th. That is a very complicated one. So that's the end of the chain rule for polynomials. And now we'll move to chain rule for e functions and natural log functions.